How's it going, guys? Quick video on Slort from Proving Grounds today. So we see port 21 SMB 3306. For MySQL we will need credentials, so we can cross that out. We see 4443, which is a HTTP port, and we also see 8080. So we need to enumerate 8080 and 443, and let's save those for later. Right now, let's go ahead and get the low-hanging fruits out of the way. Let's check for null login for SMB client. And SMB does not have null login. Let's try enum for Linux. There's nothing useful from enum for Linux. Now let's move on to the web ports. What I always do is first look at the tabs that I can open up at the top. So we see applications, see FAQs, and just look for any information that we can use. And here we see a PHP info. On this page we successfully identified a valid user called Rupert. As you can see, it says C users Rupert, updated local temp. So we can put this in our notes for a possible user. Whenever I find a PHP info page, I always do Control F and look for admin and just click through and try to look for any credentials that are on this web page. But in this case, we did not find any further information, but we will save this dashboard / PHP info page just to save it for our notes for later. Navigating to port 443 or 4443, we see that the pages pretty much reflect each other, and we aren't able to click on the PHP My Admin page to log in. So let's go ahead and use FerexBuster and try to find more directories within these web pages. Whenever you're working with a Windows machine, you always want to use the lowercase .txt files, since Windows is not case sensitive. So if you use a regular word list, you will get a bunch of duplicates. Using wrapped lowercase files, we see this index.php page equals main.php. This looks a little suspicious. It looks like a possible LFI or RFI vulnerability. So let's go ahead and check it out. So we get this page, and there are other directories up here. Let's go ahead and use ff to see if we have any other variables other than page. So we're going to use the wrap large words.txt file. So we're going to do ff-w and set our word list to wrap large words.txt :fuzz. And then we do -u for the URL, set the URL, and then within the URL, we replace the variable, so the page variable, we've replaced that page variable with fuzz. And then let's take this out. So fs is filter size. So as you can see, when we run that command, a bunch of web pages come out with a size of 27. So we will filter the size, so fs27, to remove all of the noise. We were not able to identify any other variables. So now let's try to fuzz for other web pages. So this time we're going to fuzz for different files. So instead of context.php, we're going to fuzz to see if there are any hidden files within this web page that don't show up here. And by doing that, we're going to replace that fuzz with page and equals, and then we're going to set the fuzz as the file name. So instead of context.php, we put fuzz right here. And as you can see, the same thing happens here, where we get a bunch of noise. So let's filter the lines. Let's do FL. And these lines are 5. So let's filter 5. We navigated to the different files, but none of these files were useful. So let's navigate back to that PHP info page and let's try to call for some files that we see on here. So let's try to call for this file and see if this page returns. So we get some type of error message, but it looks like the page is just having a hard time displaying the information on the page, possibly. So let's try a PHP file, since that's what the page is showing TXT files and PHP files. So let's try to find a PHP file. Actually, let's look for the location of the PHP info document. So we see it's in cxamp htdocs dashboard php info.php. So let's copy this and paste it in here and see if the PHP info page shows on this page. And as you can see, it does. So let's figure out what we can do with this vulnerability in order to get a remote code execution. First, instead of uploading a file to the Slort machine, let's try to execute a file directly from my Kali machine. So I'm going to go to my tools directory and I have a netcat64.exe file here. So I'm going to try to call this netcat64 file and get a reverse shell. So I'm going to set up my Impact SMB server. So I already had the address running, so let's run it again. And now it's working. Set up a netcat listener, RL wrap, and let's set it for 4443. Now let's try to call for that file. I'm going to put our ton0 address, and then our share name, which is hex, and then the file name, netcat64.exe, and then we're going to do the command for netcat64. cmd.exe, and then our ton0 address once again, and then we're going to put our port 4443, and that did not work, but as you can see we did get a connection back. So instead of using netcat64, let's try to call a PHP reverse shell. So we're going to go over here, set our filter to Windows, and then we're going to search for PHP, and we're going to use Ivan, this Ivan reverse shell, and let's set this to 4443, and then make sure your shell is set to CMD, and then you're going to press copy and make that a file. In my tools directory I have it set as ivan.php, and I have it set to port 4443. So save that file, and then I'm gonna go back to the site, and instead of calling for netcat64.exe, we're gonna call for ivan.php. And now let's go see if we got a connection back, and we do. Who am I? We are Rupert. OMI/all. We do not have SE impersonate privilege. But for this machine, you do not need WinPs. We're going to navigate to C, dir, and as you can see, there's a backups directory. This looks very suspicious. So this pretty much gives away the Windows privilege escalation. You don't really need to run any scripts. If there's a backup directory, it's either some backup files for the SAM and system files, or there's something else. So let's navigate to the backup directory. And there's this tftp.exe file, and let's first see what this txt file says. So more backup.txt. There's a bunch of information here. Let's read this info.txt, and as you can see, this tftp.exe file is running every 5 minutes. So we're going to see if we can replace this TFTP file and replace it with a MSF Venom reverse shell. But first, let's check our privileges for this share. So we're going to use iCackles, and then C backup, And as you can see, built-in users have full access to this drive. So that tells us that we can replace the file. Just to check for due diligence, let's check for tftp.exe. And it says built-in users have full access. Let's go ahead and use MSF Venom to replace this file. So we're going to do MSF Venom -p Windows x64 shell underscore reverse underscore TCP. Set your ton0 as the L host and set your L port. We always want to use a open port, and FTP is open, so we're going to use port 21 -F exe and -O and set the out port for the file. And we're going to set it as tftp.exe. Alright, now all we have to do is copy over this file. So we're going to use certutil. And before we copy over the file, let's make a backup of this tftp.exe file. We've renamed it to tftp.exe.back. Now let's use certutil to copy over that tftp.exe file, and we have to set up our Python listener. Alright, and we now have ftp.exe set up. So now let's set up a listener, our wrap, port 21, and now all we have to do is wait 5 minutes and we should get a show. And we are now the administrator. And if you were unable to get a shell, always go to frevshells.com and you can go to MSF Venom and just try different payloads. So you can try a stageless reverse shell, or you can try a stage reverse shell to see if that makes a difference. And before you use a reverse shell, if you can, always check for the architecture of the system using system info. And this system is a x64, so our MSF Venom payload was correct. And thanks for watching.